Lesson 2 is called significant digits or significant figures, or it's often called, for short, Sig Figs, which is significant figures because it rhymes, Sig Figs. Okay? It's really the rules for rounding off. In particular, it's the rules for rounding off when you're comparing different types of measurements from different instruments of different accuracy. What if, Mr. Dueck, I'm using a really, really good scale and it's accurate to 1,000th of a gram, but I'm also using a meter stick that only has centimeters, which really isn't that accurate then, because it means I'm kind of guessing in the... how do I compare? How do I round up? How do I do math with numbers? How accurate should I be? So I wrote here, what's the difference between $600 and $599.87 besides the obvious, well, there's 13 cents difference? And the answer is one is more precise or accurate, more precise than the other. Scientifically, we say one has more relevant or significant digits than the other. Natalie, I've taught Sig Figs for years, and I've learned it's much easier for me to show you, have you figure out the pattern, and then give you the rule in English on how to do Sig Figs. I used to give the rule, so I'm just going to show you. Turns out 600 has 1 Sig Fig. $599.87 has 5 Sig Figs. Okay, I'm starting to see pat. Wait, let's keep going. So, rules for Sig Figs. 456 has 3 Sig Figs. 0.9723 has, anyone want to guess? 4. Okay. Now, put your pencils down, look up. And a program is supposed to open really quick because I hit the hotkey, but maybe it's not going to work. Come on, software, you can do it. Note to self, should have opened this sooner. Pause the video for 1 sec. Don't write these down, just watch. How many Sig Figs? How many Sig Figs? 2. How many Sig Figs? 2. How many Sig Figs? 3. How many Sig Figs? 3. How many Sig Figs? How many Sig Figs? Am I writing big enough, Hayden, for you to read back there? Okay. 0, 0, 0, 2, 3, 0. We say that has 3 Sig Figs. So, what are we saying here? First of all, for numbers to the left of the decimal point, you don't count the zeros. Here's what we're really saying. We're saying that when we measured this, we know it was around 4,500, let's say, kilograms. It could have been 4,499, could have been 4,503. I just know it was around 4,500 kilograms. What I'm really saying is this digit here is a rounded off guess. Here, this digit is the rounded off guess. I measured this and I know it was 4,000, really close to 50. Could have been 4,049, 4,048, 4,052. I don't know, but I know the 5 is right. I just don't know about the last digit. Okay? When we're talking about decimals, we would say, okay, these are accurate. Now, the reason this has 4 sig figs is what we're saying is we actually measured it this accurately. It just so happens, Natalie, that those last 2 numbers, when I measured them, were zeros, and that's why I wrote them down, is I measured that accurate, and it wasn't a 1 or a 2 that I happened to measure, just whatever the scale or meter stick or whatever instrument that I was using, it was a 0 there and a 0 there, so I'll write them afterwards. And because it's so unusual to write numbers, to write extra zeros, that's how you know, oh, those are significant, those were measured. Those were measured. That would be a measured 0. So, pick up your pencils, back to our notes. This 690, this second one, not the first one, this second one, how many sig figs does 690 have? 2. Mr. Dueck? Yeah, Robbie. What if I actually wanted that 0 to count? What if I measured this and I measured this accurate and I just happened to get a 0? Well, then what you would do is you would put a decimal there, and that's your way of saying to whoever's looking at this measurement, oh, by the way, I actually measured this accurate. This is where I rounded off to, and this just happened to be a 0. This would have 3 sig figs. So zeros to the left of a decimal count. If there's no decimal point, zeros to the left don't count, unless they're between 2 numbers. Zeros to the right of a decimal are tricky. If there are non-zero numbers to the left of a 0, they count. Otherwise, we ignore them. We're going to do these first 2 later. We're going to first of all do the 0.0035. How many sig figs? Take a guess. 2. You see why I said it's easier to show you the pattern than explain this in English? How many sig figs for the next one? 3. Let's go back to the top here. 67.00. 4 sig figs, because why would they add those extra zeros after the decimal point? They must have measured that. Otherwise, you would just say 67. So we have to assume that those were measured values, and they just happen to be zeros. Okay, so this has 4. How many sig figs for the next one do you think? 6. I was going to say 5 because I can't count. 6. How many sig figs for 0.008900? 4. Okay. Is that all right, Cam? It's easier to show you the pattern. In English, I mean, okay, it's 0. You can look at the English rules. It's easier to do the pattern. You all right? So then we come to this. How do I do math with numbers with differing sig figs? And this is for those of you that were wondering about my answer key yesterday. I was rounding off to the correct number of sig figs. And that's why when some of you were asking me, how many decimal places, what did we round off to? I couldn't give you an answer because the rule varied from question to question. The easiest rule, it turns out, Derek, is multiplying and dividing. Isabella, the toughest rule, the yuckiest rule, adding and subtracting. Multiplying and dividing, which you used to call rounding off, but now we're going to say rounding off correctly in science. We go like this. How many sig... First of all, you go to your calculator and you just type it in. So, and now we pause. Fascinating, shut up. Here we go. 6.74 times 2.1232. Okay, so all of our calculators say that. Yeah. Now, what are the rules? What do I round off to? 13, 13.4? How? We go like this. With a pencil or with your pen, how many sig figs does 6.74 have? How many sig figs does 2.0000? How many? The second, Taylor? You're going to round off to 3 sig figs. You round off to the fewest number of sig figs in your answer, in your data. So, 1 sig fig, 2 sig figs. The 3 sig figs is right there, and you'll notice you've never heard me say decimal places because it's going to vary from number. That's when people were saying, how many decimal places? Can't answer that. So that's a 4. What's next to the 4? Am I going to leave the 4 a 4, or is it going to round up? to the correct number of sig figs, this would be 13.5. B. 6.4 divided by 9.088. How many sig figs am I going to round this one off to? 2. Because 2 sig figs, 4 sig figs. So 1, 2. And again, I can never say, Natalie, people are saying, how many decimal places? I'll never be able to answer that, because here, this one's 2 sig figs is 2 decimal places, where in the previous example, 3 sig figs was only 1 decimal place. So I can't answer it that way. I can only answer it in terms of sig figs. So it's a 0. Is the 0 going to stay a 0, or is it going to round up to a 1? Because there's a 4 next to it, so it's going to be 0.70. And that 0 there is significant, which is why you're putting it there. You're saying, hey, when I did the measurement, I know that's a 0. Everything else was maybe inaccurate, but I know I was accurate that far. Does that make sense? James? Yes? Good. Learning names. So rule 1, don't round off until you do all your calculations. Rule 2, you round to the smallest number of sig figs represented. So I did put the answers here, but we got them right. Okay. So let's try example 1. And I find for multiplying and dividing, Hayden, I can usually do these all on my calculator without having to rewrite them, showing no work. Adding and subtracting, the rule is not as convenient, unfortunately. Thankfully, 90% of what we do in Physics 11 is multiplying and dividing. So I'll show you the adding and subtracting rule. I'll test you on it here. And then we'll probably put it to bed and never use it for the rest of the year. I'll test you on it, this unit, and then you never see. Anyways, 13.567 times 5.56. What's the correct answer to the correct number of sig figs going to be? I'll give you a hint. Starts with a 7. 75. Am I right? Is it 75.4325? Okay. How many sig figs in the first number? 5. And you know what? Ethan. No, yeah, Ethan. Ethan's clued in. Hey, Dueck, why don't I just look at the smallest sig fig number? And you're right. I wouldn't even look at the 5 sig fig. I would say 3 sig figs, because that's obvious, the fewest. I'm going to go to 3 sig figs. I probably won't even look at that big, long number. How many sig figs am I rounding off to? 3. So the third digit is right there. Is the 4 going to stay a 4 or get bumped up? 75.4. Example 2, going across. Just glancing at this before we even start, how many sig figs are we going to round off to? 2. And this is why I said you'll find most of you multiplying and dividing, you'll be able to just kind of figure it out in your head and go straight to your calculator. 13.567 times 5.5. Okay, so 2 sig figs is right there. Is the 4 going to stay a 4 or become a 5? How do I know, Kent? What's the rule, by the way? If the digit to the right is what or bigger? A 5 or bigger, you round up, otherwise it stays the same. So this is going to be, you could also do that, Cam. That's still 2 sig figs. Is that more work? Then I'm not going to bother putting a decimal there. The only time I would put a decimal there is if instead of a 5, if I had a 0 there, then I'd have to put the decimal to show 2 sig figs. Speaking of 2 sig figs, I think this next one is 2 sig figs. 5.0 is 2 sig figs. So 13.567 times 5.0. I probably didn't need to type the 0.0, but some of you would freak if I didn't, so okay. 2 sig figs. Here, 68. Yes? How many sig figs in this next one? Just 1. Okay. I guess that means that number 5 came from a measuring device that was just not very accurate. You know? So we can't express our number, Jaden, with any accuracy either if we were doing research. 13.567 times 5. 1 sig fig. Now that's 1 sig fig. That would be 2 sig figs, so now you definitely don't want to put a decimal there. As soon as you put the decimal there, you're saying I meant that 0 to be a significant figure, so I won't do that. That's multiple. Oh, by the way, we times. The rule is the same for dividing. Next page. Adding and subtracting is tougher, unfortunately. Adding and subtracting, Robbie, the easier ones I can do in my head. The yuckier ones, I still need to rewrite them. So you ready? I'm going to show you the rewrite, doing it the long way method. We'll practice that, and then on the very last one, I'll challenge you to see if you can do it in your head. What you have to do until you get good is rewrite the adding and subtracting questions vertically, Gabriella. Gabriella, yes? Yeah, vertically. Carefully lining up the decimal points. So I typed this way on purpose. I lined up the decimal points. Then you're going to extend this bar like that. And then what you're going to do is you're going to fill in any missing digits with question marks. Like that. Or X's, or I usually put question marks because that's me saying, don't know what goes there, don't know what goes there. Do we round off before we go to our calculator? Nope, so type this into your calculator. Yo. You have a question mark button? Oh, no, yeah, no, don't worry about it. You just type this in. Were you being sarcastically funny? Well played. So when you type it in, you, Derek, minus the question mark, but get 13.57, yes? Here's what you're going to round off to. Now, first of all, how many sig figs does the first number have? 4. How many sig figs does the second number have? 2. Unfortunately, that has nothing to do with the final number of sig figs. It's not going to be 4. It might be, but here's what it is instead. This is the last column where I have no question marks. That's the number of decimal points I'm going to round off to. I'm going to round off right to there. So this is going to be 13.6. Which you'll notice is 3 sig figs and didn't show up anywhere in the previous. It's line, and that's why I say, Taylor, at the beginning, line them up vertically so the decimal points. If you do a bunch of these, you reach the point where you can just visualize that and line them up and see where the missing gaps, where the question marks would go. Oh, this is where I'll round off to, and we'll try one like that eventually. But for now, so what's the rule? Use all the known digits in the calculation. Don't round off. Round off to the last decimal place that both answers have in common. The last decimal place where you know everything. Okay? So, if you want a summary, because some of you like this, the rule for multiplication and division is the least number of sig figs. The rule for addition and subtraction is the least number of decimal places. Did I have more examples? Okay. Don't have more examples yet. You know what? We have room right here. Here's the problem. Most of the time, when they give you a math adding question, they're going to write it like this. 6.32 plus 4.917 minus 12.6. They're not going to write them vertically. They're going to write it like that. So if they give me one like this, this is when I rewrite it. I'm going to rewrite it vertically. and I'm going to keep my decimal points in line. 6.32, 4.917, and that's a plus. Take away 12.6. It looks like on this question, how many decimal places am I going to end up going to? Just one. And you'll notice this time I didn't say how many sig figs am I going to end up going to. Adding and subtracting, I have to go back to talking about decimal places, not sig figs. I'm going to do the math. 6.32 plus 4.917 minus 12.6. Oh, negative. Okay, that's a fluke. What happens when I make it up? One decimal place. Negative 1 point what? 4. Right? Which has 2 sig figs, which never appeared anywhere in the original questions. Okay. Okay. I am giving you lots of practice. So first of all, you have how many sig figs for each number. One of the lovely things about scientific notation is it's really easy to tell the number of sig figs if you give me the number in scientific notation, because really all you're staring at is this: 4, 3, 2. This is one place where scientific notation really shines. Anyways, how many sig figs? Then you're going to be solve problems, round accordingly, multiplying and dividing here. Then we had some adding and subtracting, and I did attach the answers, so mark it. In other words, make sure you're doing it right. Don't do it is possible to do this all wrong, Hayden, and just never know, because my calculator says it's all about can you interpret what your calculator says. Okay? But first, put your pencils down. I got to show you a cool video.